5 mass extinctions have swept across Earth in the past half-billion years, each obliterating over 75% of all species. Of those 5, 2 are so well known that they've inspired science fiction stories about killer asteroids and deadly viruses. But one of the lesser-known events is so bizarre it might make you rethink just how fragile our own existence really is. About 260 million years ago, Earth was struck by a comet or an asteroid, and it wasn't the impact itself that triggered the mass extinction. It was what happened afterward. That extinction event, called the Capitanian, would wipe out more than 90% of all marine species and 70% of terrestrial vertebrates. And it's given scientists a rare glimpse into the effects of a disaster that only happened once before in Earth's history. To hear more ways that our planet could end, including a real-life example of a civilization wiped out by its own supervolcano, stay tuned for more information. Now back to our story. The Capitanian Extinction is also unique because we know what caused it. Unlike other mass extinctions that may have had multiple factors or no obvious cause at all, the Capitanian has been tied directly to a single impact event. And because of just how recent it is in Earth's history, there's an incredible amount of data to work with, including shocked quartz samples from around the world, which are small bits of quartz that get physically altered when they experience extreme pressures, like those found in an impact event. There's even a layer of sediment in places like Nevada that contains the radioactive element iridium, which often comes from space. All of this evidence points to a large object from space smashing into Earth about 3 kilometers or 2 miles below the surface. The impact unleashed tremendous energy. Some estimates suggest that the impactor was as wide as 10 kilometers or 6 miles and that the impact itself released between 280 and 300 trillion joules of energy. For some real context here, the largest nuclear weapon ever detonated by humans, the Tsar Bomba, released roughly 50 million joules of energy. So this impact was over 6,000 times more powerful than the biggest nuke we've ever built. This is where the story takes a turn for the strange. You see, the Capitanian extinction wasn't caused by the impact itself. In fact, the impact didn't even happen on land. It occurred in the ocean off the coast of what's now Siberia. But the real damage was done after the object from space hit the water. You see, when the impactor struck the ocean, it didn't just gouge out a massive new crater, it also displaced a staggering amount of water. The volume of water displaced by the impact was comparable to all the water in the Mediterranean Sea. And as that water column collapsed, it generated giant tsunami waves that raced across the globe at speeds of over 800 kilometers per hour or 500 miles per hour. Those tsunamis were over 100 meters or 300 feet tall, and they unleashed tremendous energy onto any land they came across. But there's yet another twist. The force of the waves actually pushed a lot of water back into the newly formed crater. And because the crater was so deep, much deeper than any ocean trench ever found on Earth, it created a massive low-pressure environment. As the water rushed back into the crater to equalize the pressure, it sucked up tons of marine life before plunging it to the bottom of the sea. Marine organisms weren't the only ones affected either. Plants and terrestrial animals also suffered big losses during the Capitanian. And it seems likely that the culprit was the same thing that devastated the oceans: sediment. The tsunami waves scraped sediment off the ocean floor and deposited it on land, which blocked out the sun and killed off most of the plants on land. Without plants to produce oxygen, many terrestrial animals died, too. It's important to note that while the Capitanian is definitely a mass extinction event, the recovery wasn't uniform across the board. For instance, insects seem to bounce back faster than vertebrates. And there were likely multiple pulses of extinction within the larger event, meaning that the Capitanian wasn't one continuous period of ecological devastation. Life did recover, but it took tens of millions of years for the diversity of life to return to what it had been before the Capitanian. As terrifying as the Capitanian event is, it's not exactly unique. We have a ton of evidence of large asteroids and comets impacting Earth throughout the planet's history. In fact, impacts are thought to have played a major role in the evolution of life on Earth, providing a source of both genetic material and mass extinctions that cleared out competition for new life forms. One notable example is the Ordovician-Silurian extinction, which took place around 440 million years ago, wiping out an estimated 85% of all species. And while the cause of this event is still hotly debated, evidence suggests that an asteroid impact may have played a major role in the mass extinction. In fact, researchers may have found the crater from that impact in Oman, nearly 1 kilometer beneath the surface and buried under hundreds of meters of sedimentary rock. But the Capitanian isn't the only time that an impact event had lasting effects far beyond the immediate aftermath. About 200 million years ago, yet another mass extinction swept across the globe, killing an estimated 76% of all species. This event, called the end-Gulofan, also happened in the ocean, likely starting in the shallow seas that covered what's now the western United States. Unlike the Capitanian, however, the end-Gulofan had a more drawn-out beginning. Scientists think that volcanic activity in what's now the western U.S. gradually poisoned the oceans with carbon dioxide over thousands of years. High levels of CO2 led to ocean acidification and global warming, which disrupted ocean currents and caused the collapse of the Gulf Stream. This slowed down the exchange of heat between the equator and the poles, which led to an ice age. At the same time, more volcanic eruptions in what's now Siberia added even more carbon dioxide to the atmosphere, which led to runaway global warming. Temperatures increased by an average of 3 degrees Celsius, or 5.4 degrees Fahrenheit, and sea levels rose by over 100 meters, or 300 feet. And yet somehow life still managed to limp on. Then the asteroid struck. While the impact itself may have only been slightly larger than the Chicxulub event that killed off the dinosaurs, it had devastating consequences. First, the asteroid triggered another massive tsunami that slammed into already battered coastlines. Second, it caused massive wildfires by igniting methane hydrates. These are deposits of methane gas that occur in cold ocean waters, and they contain huge amounts of flammable fuel. The fires released even more carbon dioxide into the atmosphere, further exacerbating global warming. Finally, the asteroid also kicked up enormous amounts of dust and sulfate aerosols into the atmosphere. These particles reflected sunlight away from Earth, causing temperatures to plummet and leading to another ice age. In short, the asteroid basically tipped Earth's climate system over the edge. These extreme conditions wiped out 90% of all marine species and 70% of terrestrial vertebrates. Once again, though, life did manage to survive and eventually rebounded. All three of these events show us just how close we are to the edge. Just one super volcanic eruption or one large asteroid impact away from losing our comfortable little slice of paradise. And it's not like such events are unheard of in modern times. Consider Mount Toba in Indonesia. About 74,000 years ago, it erupted in a cataclysmic blast that sent 2,800 cubic kilometers of ash and pumice into the air. That's enough material to cover the entire state of Florida under 6 meters or 20 feet of ash. The eruption unleashed 2,800 cubic kilometers of ash and pumice, which is about 300 times more material than the Mount Street. Helen's eruption in 1980. Toba was so big that it caused massive climate disruption across the globe. During the years following the eruption, Earth experienced a volcanic winter. The ash and sulfate aerosols in the atmosphere blocked out the sun, causing temperatures to drop by 5 degrees Celsius or 9 degrees Fahrenheit. It's believed that the eruption also caused a younger Dryas ice age, which lasted for about 1,300 years and ended around 11,500 years ago. Humans were thankfully safe from the worst of the eruption. since the closest human population was in Africa, thousands of kilometers away. But things could have turned out very differently if the eruption had happened just a few thousand years earlier. Human ancestors were widespread across southern and eastern Africa at the time, with some groups living as far west as the Middle East and as far east as Australia. If the eruption had occurred just a few thousand years earlier, it's possible that the massive climate disruption could have wiped out humanity before we had a chance to get started. So while the future looks bright for us, let's just say that we should keep an eye on the skies. Because of all the ways that Earth could end, perhaps being flattened by an asteroid or drowned by a tsunami isn't the worst-case scenario. It's the sudden onset of an ice age right in the middle of summer that will truly be a game-changer. Thanks for watching this episode, and thanks especially to our supporters who make it possible for us to bring these quirky stories about the ways the world could end to a wide audience. To learn how you can support us and all the perks we have to say thank you, head over to our support page.